Welcome back to KSET previous year question and solution classes. Today I will discuss classical mechanics 2015 part. Okay. So here the question is like this: if the force acting on a particle are conservative, okay, so then which of the following quantities is conserved? First, total energy, linear momentum, angular momentum, and both linear and angular momentum. So in the four options, which of the following is correct? We have to choose. So here they clearly mention that force acting on a particle. So what is total energy? Total energy is nothing but final energy minus initial energy. You can also represent the total energy as final energy minus initial energy. This final energy minus initial energy is also nothing but work done. Okay, and also we know that work done, so work done is equal to force into displacement, right? If the force acting on a particle, the particle may be, it has to be displaced. Okay, so if a particle acting on the, if a force acting on this chalk piece, it has to be take some momentum, right? So otherwise, if the force is negligible, then the particle does not move. Okay, so but if the particle does not move, then what it means? It is at rest. That means the displacement is 0. Then also the work done is conservative. So then work done is nothing but total energy. So therefore option A is correct. So the total energy, kinetic energy and potential energy is conservative. That means if for example let us consider a chalk piece is at rest. Okay, sorry, let us take a duster. Duster is at rest now. Okay, it has some potential energy. If a force acting on this duster, it try to move, it takes some momentum, then potential energy and also kinetic energy has to be conserved. So total energy is conserved. For a circular and parabolic orbits in an attractive 1 by r, potential having the same angular momentum, the perihelion distance of parabola is, the perihelion distance of the parabola. The perihelion means, so the distance of the planets and the sun, the center of the position and the distance we are going to measure the point, distance is more than okay. So then here for an orbit we know that r is equal to L divided by mk square. Perihelion means, for example, let us consider a motion of a planet around the sun. For example, this is the sun and the planet is revolving around. Okay, so the perihelion means so if suppose this is the planet, the perihelion means the point where the planet is closest to the sun, that part we can represent as perihelion. And another concept will be arises, which is aphelion. So what is aphelion? The point where the furthest distance between the sun and the planet, is called aphelion. So perihelion means the closest point between the sun and the planet, and aphelion means the furthest distance from the sun and the planet. Okay, so here if it is circle, the orbit r is equal to L divided by mk square, and if it is parabola, r is equal to L divided by mk square into 1 divided by 1 plus cos theta. So, this is for parabola. Okay, this is for parabola, and here the condition is given: the potential having the same angular momentum, the perihelion distance of parabola is, and the circle and parabolic orbits in an attractive 1 by r. So, that is central force. So, it looks like it double the radius of the circle, or equal to the radius of the circle, or half the radius of the circle, or thrice the radius of the circle. Here when theta is equal to 0 for a parabolic, then r is equal to L divided by m k square into 1 plus 1, because cos 0 is 1. So, which is equal to L divided by 2 into m k square. So, see, L k square is nothing but r. So, r. So, which is r is equal to 1 by 2 r prime. If suppose this is r prime, so r is equal to 1 by 2 r prime. Okay. Sorry, r prime is equal to 1 by 2 into r. So, then therefore, half of the radius of the circle, it looks like half of the radius of the circle. Answer is option C. So, this is the question: the Lagrangian for a compound pendulum is. So, we have to calculate the Lagrangian for a compound pendulum. So, for example, let us consider here there is a reference axis where potential is equal to 0. Upside the potential is positive, in the downside let us consider potential is negative. So, from the point at the origin O, there is a point. From this point, a pendulum, it is a solid pendulum, rigid pendulum. Okay, it is a rigid body. Okay, so which is stitched here, or which is fixed here, and it is oscillating like this. It is vertically moving like this. Okay. So, this distance I am considering as a L. Let us consider just a moment of time. It is oscillated, and the position next it is here. Okay, the point from here to here. If I join a straight line. Here let us consider this is O, P, and this is P dash, and which makes an angle theta. So, this pendulum is rotating like this. Okay. So, we have to calculate a Lagrangian, okay, for a straight line, for a vertical direction. For a vertical direction, a fixed horizontal axis. So, this horizontal axis is fixed. So, this axis is fixed, and it is vertically oscillating. Okay. So, for example, let us consider this is a rigid body which is oscillating like this. So, for this type of a rigid body, we should calculate the Lagrangian. So, we know that Lagrangian is nothing but kinetic energy minus potential energy. Okay. So, I am going to rub this part. So, we know that Lagrangian is nothing but kinetic energy minus potential energy. So, what is kinetic energy? For a rotating rigid body, the kinetic energy is of I theta dot square. So, this is a kinetic energy, and we can also write this as T is equal to of I omega square, because theta dot is nothing but omega, angular velocity, and potential energy. So, what is potential energy? We know that V is equal to mgh. Potential energy V is equal to mgh. So, height we should have to calculate. So, from the diagram it looks like a triangle with 90 degree. So, it is like this. 90 degree, and this is theta, and this length we have to calculate. This is OP. So L, we know that cos theta is equal to adjacent OP by L. So therefore OP is equal to L cos theta. Okay. So therefore V is equal to mg. This OP is nothing but L cos theta. So V is equal to mg L cos theta. Now see, I am going to rub this part, okay, because I have to write the Lagrangian here. So therefore kinetic energy is of I omega square minus of potential energy is minus mg L cos theta, because so it is towards the ground. So L is equal to of I omega square minus into minus plus mg L cos theta. So option B is correct. Hamilton's canonical equation of motions are Qi is equal to dou h by dou p and Pi is equal to Pi dot is equal to dou h by dou Qi. So Hamiltonian equations of motion is Qi dot is equal to dou h by dou Pi and Pi dot is equal to minus of dou h by dou Qi. So you should remember, for P it should be negative and for Q it should be positive. Okay. Next, when the body is constrained so as to rotate only about a fixed axis, then the moment of inertia is 0, variable, constant and non-zero. So it is constant, and 0 and non-zero are similar but not an answer. So constant. So why constant? See, for example, let us consider this is a body, a rigid body, so which is fixed. So see, in this point is fixed and it is rotating. Moment of inertia means center of mass and r square, sorry, mass and r square. Okay, that means the particle position or center of mass position. So then I is equal to m r square, which is fixed. So r square is not changing. The radius of this, for example, let us consider this is the point where you are going to measure a moment of inertia. So then that mass of that point into r square, so which is which is fixed. So constant, option number C is correct. The rest mass of an electron is m naught. When it is moves with the velocity of 0.6 c, then its mass is m naught, 5 by 4 m naught, 4 by 5 m naught and 2 m naught. So the rest mass, see, we know that if a particle moves with a velocity of light, so then its mass will also change. It has to be take some correction. So that is Lorentz correction, that is m is equal to gamma into m naught. So what is this gamma? Gamma is nothing but 1 divided by square root of 1 minus v square by c square. So which is equal to m naught into 1 divided by square root of 1 minus v square. So what is v? 0.6. So 0.6 whole square into c square by c square. C square cancel. Okay. So which is equal to m naught divided by square root of 1 minus 0.6 is nothing but, so 6 by 10 whole square. So then which is equal to m naught divided by square root of 1 minus c. So then it is 100 minus 36 divided by 100, right? So which is equal to m naught divided by square root of 100 minus 36 means 64. So 64 divided by 100. So which is equal to m naught. If 64 come outside, it will becomes 8. So 8 by 10, which is equal to 2 4s are 2 5s are. So answer is 5 by 4 m naught. So answer is m is equal to 5 by 4 m naught. So option B is correct. A cylinder rolling without slipping down a rigid inclined plane, inclined down a rough inclined plane of angle theta is an example. So that means let us consider a inclined plane. In this inclined plane, a rigid cylinder. Okay. So let us consider this is cylinder, and this cylinder is rolling. It is rolling without slipping. So it is rolling means it has rotational motion and as well as angular motion. So it has angular motion plus rotation motion. Okay. So that is mvr plus m omega square r. So it has linear motion and as well as rotation motion. So therefore, it is possible to write an equation for this. So we know that holonomic means it is possible to write an equation for any body. It is called holonomic. It is expressed in terms of some coordinate. And also, what is celeronomic? Celeronomic means a motion, a constant motion which is independent of time. So here it is also independent of time. It does not depend on time. Okay. And is conservative system. Celeronomic conservative system only? No, because it is also holonomic. So celeronomic, holonomic conservative system only, and conservative system only, celeronomic system only. So it has celeronomic, holonomic and conservative. So option B is correct.